All right. So, important announcement. I made a mistake. It's kind of a big one. So, the weights on your grade for this class were misrepresented. So the syllabus says that, I transposed two numbers. Tests are supposed to be 50%, the semester exam is 15. I transposed those two numbers inside of the grade book. I fixed that this morning.
Oh.
So if you saw your grade jump for some reason, that was the reason, okay? So if your grade moved and you're like, whoa, that looks more different than what it was, I just checked it, and all of a sudden, a homework assignment that I did, my grade changed a lot, that's why things changed, okay? So I goofed that up, I fixed it this morning, just to, make sure that everybody's on the same page. I want to announce that. If you have questions or whatever, I can deal with those on an individual basis, but I think that needed to be said. I don't want to do that and not say anything, because that's a pretty big one. For some of us, it may have done literally nothing, right? All right. Next up, I had a couple of people asking about one of the Delta Math problems from the virtual days assignment. I want to kind of go over how to deal with that to make sure that we can do that effectively. So if we look at the chapter 14 Delta Math, I think it was the last section where the people were having the issues. Okay. So some of the issues were just in making sure that we're able to accurately place things. Some of them were in how to use the setup and get this to do what you were supposed to get it to do to take your answer. Let's run through an example or two here, just so that we feel okay. Again, this is also excellent review for what we had just been doing, because it's basically the same thing. Now, this is not something that I think that it's realistic that you would be able to do in your head without writing anything down. So I'm just going to do this as an example. So I'm going to start by factoring. So if I look at the first, or the numerator, what can I factor from the numerator? Or how can I factor the numerator?
-2x.
Yeah, so you could take a 2x or negative 2x. I think it probably makes more sense to take the negative. And we factor the denominator, we take out an x. And then we can reduce here, right? I can reduce out those factors of x. That's going to create a removable discontinuity. So I take that part that I crossed out and I set it equal to 0. And then to get the y, I take the part that I canceled out and I plug it in. So I'm going to get 0, 4 as a removable discontinuity. So I'm going to go to my graph, click on the whole and place it at,
I think you have to drag it.
sorry, drag it to, oops, x equals 0. And notice as you drag it along, like when you get to one of the major parts, like it'll kind of like whoop,
Snap in place.
snap into place where you know it's at like an exact value. Everybody's okay there? Okay. Now that I have this reduced, let's get our vertical asymptote. So just take that denominator, set it equal to 0. Okay, so I'll take my vertical asymptote and drag that over to -2. Everybody's okay there? And then we'll get our x-intercept, taking the numerator, set it equal to 0. So there's an x-intercept. Let's do our y-intercept next. So to do that, we're just plugging 0 in for x. So that's going to give me 4. But notice that, yes, sir.
Sorry for interrupting. Can I borrow a calculator for a test?
Yeah,
Hi,
grab one
Ty,
off the
would you-
desk.
Hey,
You're finally
guys.
doing
What
this
class is
accounting
this?
test. Pre-calculus. Been there-
Pre-calc?
Yeah, been there, done
Been there,
that.
done that. Wow.
What do you notice here, though? If I'm plugging in 0, that was the removable discontinuity value, right? So I don't really want to do that. Okay. Notice that I already have 0, 4 placed with a hole, so I wouldn't want to cover it now with a new y-intercept. So if I had accidentally clicked this and was like, oh no, I don't actually want that, if you just click it again, it goes away and it stops trying to do a y-intercept. The last thing is then a horizontal asymptote. To do that, I need to compare the degrees. Degree 1 over degree 1 means that I have a horizontal asymptote at y equals leading coefficient over leading coefficient, so -2 over 1. So I do have a horizontal asymptote. I'll drag that down to -2. And then I'll hit plot. Now that I've placed everything that I can, and hit submit answer. Actually, let's do this first. Let's say that I hadn't done this yet, and I try to hit and then I try to plot that. Notice it's going to give me an error and say, okay, you need something on there, right? Now I do that now, and I hit plot. Uh-oh, I made a mistake. What did we do wrong?
I think you have to plot the x-intercept again. I don't know.
No, I put it on there.
Oh.
Has to be
Is there a
precise.
What's that?
Yeah, mine.
Mine didn't work unless it was like 0.0000.
Okay, that's locked into place. That's locked into place. That's locked into place. Oops. That's locked into place, okay? That's 4. Plugged 0 in, I got
Did you do the factoring wrong?
4. Did I do the factoring wrong? Sure did. Dum-dum. Look, there's supposed to be a 3 here. Oh! Okay. Great. All right, so that should be negative 2/3.
You are so good. Yeah, I know. I just used, I used.
I don't know, try that. Nope, I don't got it, because see, it didn't go through. Nope. Oh, my goodness. But that's gonna change. Does that change anything? Yes, it does. Changes this guy, right? Okay, so I know it's not right because see the graph isn't going through. The issue is with my horizontal asymptote, so leading coefficient over leading coefficient. Try that again. Think that looks like it's going through everything now. Let's try it. I don't know, let's try it. Correct. Let's do another one, eh? Oh, this one should be easy to make it work. Factor the numerator. Nothing to reduce. So no whole or removable discontinuity, right? Is everybody okay there? My vertical asymptote, set the denominator equal to 0 and solve. Everybody okay there?
What do you do negative for us?
Negative 4x is equal to 0. Divide both sides by negative 4, and x equals 0. Right? You're good. I just did it quickly in my head. Is that okay?
Yeah.
We're all right? Horizontal asymptote, degree 1 over degree 1. So that should be leading coefficient over leading coefficient. Or like that guy. My x-intercept is going to be the numerator set equal to 0. The y-intercept would be y's in for 0, so that's going to be negative or 15 over. Oh, can't happen, right? Why not? Vertical asymptote set x equals 0, so there won't be a y-intercept because x equals 0 is undefined. I think that'll do it for me. Vertical asymptote there. Horizontal asymptote 1 1/4. Maybe, I don't think that's got it, but we'll put it for now. We have negative 3, 0. Plot. Looks like it's going through okay. Oops, I didn't mean to do that. Let's try it. And it took it.
Can you do one of the limit ones from the delta math?
One of the limit ones from the delta math, probably. These guys?
Yeah.
Okay. All right, so it asks, the graph of the function, blah, 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 is shown below. Write a limit to represent the function's behavior as x approaches 7 from the left. So I'm going to have LIM in here. And I'm going to have x approaches 7 And then I need that from the left. So is that the minus or plus? Yes. And then I'm just going to type this as P of x here. Okay. And then we'll just write equals. So we're looking at -7 from the left. So we're looking at this arrow. Negative infinity.
Why is it the equals and not like the approaching?
It's the limit is always equal.
Okay,
The approaches is only on the x.
okay.
Okay? It's that way every single time. We do another one?
Sure.
Okay. So the function c of x, yada, 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 is shown below. Write the limit to represent the function's behavior as x approaches 2 from either side. Okay? So LIM, and then we have c of x, and then this is always equals, this is always x, this is always approaches. Now it said 2 from either side, so just x equals 2, or x approaches 2, no superscript. And if I find x equals 2 on my graph, I trace down, either side it's heading towards the y coordinate of -3. So that's all I'm going to type here. And I'm going to hit submit. Oops. Submit.
Will we have like the approaches one on the test, or will it just be like the ones we did in class?
It'll be like I give you the picture and ask you to just write it. That's for I give you the function and ask you to graph it on your calculator. You just use the
So it
picture.
won't be like these.
I won't ask you a specific
Okay.
one like that. Daniel.
Yeah, he's that.
Sure. No problem. Do you guys feel okay on the delta maths here?
It's fine.
It's fine. Yeah, the graphing one, you have to be a little bit careful, right? You know, like, it's a little finicky, but like, it's a good to like have one of those where like you gotta make sure you get all the parts right and in the right spots. And then when you do the plot, you gotta make sure everything is like going through all the points it's supposed to and all that jazz. It's your checker before you hit submit, but you might have to adjust things a little bit or be like, oh no, that's not going through everything. What did I do wrong? And realize you factored something wrong like I did there. Like, oh my gosh, I forgot the 3. Okay? My plan here then for today is I want to talk about, before we talk about solving rational equations, which is our next major topic in this chapter, I want to do a little sidetrack and talk about like add, subtract, multiply, divide. Okay? Oh my goodness. Okay. So the rules here are the same as the rules for fractions, right? What is a rational function other than like a fraction of polynomials, right? So I'm going to do an example of each of these. First as a fraction, and then as a rational function, and talk about how we, you know, handle everything. Everybody's cool? So I'm going to start with multiply and division. Maybe we'll write that in a different order. Because with fractions, multiplying and dividing is actually easier than addition and subtraction. So let's say we have 4/5 times 35/12. So the first thing you'd want to do is you want to do a prime factorization for all the for all the integers here. So what is the prime factorization for 4? Well, 4 is not prime, right?
I don't know.
2 times 2, right? 2 times 2 is the prime factorization, right? Your prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31.
Yeah,
Seven.
very good.
Okay. What's the prime factorization of 5?
No.
Just 5, yeah. It's already a prime number, so there's nothing to do there. How about 35?
7.
5 times 7. And then 12.
2 or 4 and 3. No.
Well, 4 is not prime.
2 and 6.
6 isn't prime.
Oh. What's is it like 5?
Prime,
You're right
prime
now,
is if it's not divisible by more than one in itself, right?
2 times 2 is 3.
So remember, probably in like elementary school, you guys did stuff like this,
Yeah.
right? To draw your factor tree. And the leaves of your tree are your factors. You guys remember doing that? Maybe, vaguely, possibly. Everybody's okay? Now we can reduce tops with bottoms. Is everybody okay with what I did there? Notice that when I reduce them, they become a 1, right?
So is it just 1 times 7 or 3?
So then we multiply across. So 1 times 1 times 1 times 7 is 7. And 1 times 1 times 1 times 3 is 3. So we're 7 over 3. Is everybody okay? Let's try this now with rational functions. The procedure is going to be identical, except the way we do a prime factorization for a polynomial is different than we do a prime factorization for an integer, right? What's prime factorization going to look like for a polynomial? Like the factoring that we do for polynomials, right? We're just talking about factoring.
I'm sorry, what's the final answer?
7/3 is what it came out to be. So let's say we have these two rational functions, x squared plus 5x plus 6 over x squared minus 4 times x squared minus 5x plus 6 over x squared minus 9. First step, just like before, is to factor. And you want to make sure it's a prime factorization. So you want to make sure you've completely factored everything down as far as you can go. How do I factor x squared plus 5x plus 6?
X plus 7 is x plus 2.
Okay. How about x squared minus 4?
X minus 2 is plus 2.
Okay. And then x squared minus 5x plus 6.
X minus 3 is minus 2.
Okay. And then x squared minus 9.
X plus 3, x minus 3.
Okay. And everybody else other than Gabby knows how to do this, right?
Yes.
You're just conveniently being silent as I ask how we factor these things and letting Gabby go over work here.
Yes.
Knock it off, do some of it yourself. Okay. Now we can reduce tops and bottoms, right? So like x plus 2's in the same fraction. X plus 3's in different fractions. It's fine, as long as they're top and bottom. X minus 2's different fractions. X minus 3's different fractions.
So it's 1.
I did all the reducing I can. When I multiply across, I get 1 over 1.
1.
Just 1. Well, that was rather disappointing. I think it feels good. Like when you get to cross all that stuff off and look at how simple that answer is. Yeah.
Wait, so are 3 and 2 both prime?
The numbers 3 and 2 are both prime, but that doesn't matter to us in this problem. What matters to us in this problem is that x minus 2 is prime, because that doesn't factor anymore. Does that make sense?
Wait,
So like, if I talk about the polynomial x minus 4, this is a prime polynomial because you can't factor that anymore, even though the number 4 is not prime.
yeah.
But I can't rewrite x minus 4 as the product of two polynomials.
Yeah, I see.
You know what I mean?
Yeah.
That's prime. Does that feel okay?
How do we know if we don't need to worry about it being a prime number? Like, how do we know if the equation?
So we're doing a rational function.
Okay, so
So we care about if the polynomial is prime, not about its coefficients being prime.
okay.
So a prime polynomial is something that can't factor anymore. Right? Like x plus 2. Can I factor x plus 2 anymore? No, because I can't write that as x plus or minus something times x plus or minus something. When I multiply them together, I get x plus 2 without having to invoke like things that are not polynomials.
Okay.
Does that?
Yeah.
So basically, if you get a linear thing
Don't
and the coefficients are relatively prime, like 1 and 2 are relatively prime, like there's nothing in common between them, you're done.
Alright.
Is that okay? Does everybody feel okay on this? Do you remember doing this? Did you do this last year? It's the hope. Okay. Next example. Yeah. Let's do division. Okay. We're gonna do this as numbers first, right? So the procedure Rewrite this as a multiplication problem. I.e., if I have like A over B divided by C over D, that's A over B times the reciprocal D over C. And then it's going to be the same as the multiplication problem we did before. Okay, so I rewrite it as a multiplication problem, and then it's the same thing we just did. So prime factorization, reduce top and bottom, multiply across. So far, so good? Okay. How do I write this division problem as multiplication?
2 times 2 times 3 times, no. That's wrong.
36 over 35 times
That's 25 over 12.
25 over 12. Now we'll do our prime factorization. So,
That was
Addie,
wrong, I think.
what's the prime factorization of 36? Lauren, go ahead.
Is it 2 times 2 times 3 times 3?
Yes.
Oh.
Everybody okay there? 35 was 5 times 7. 25 is
5 times 5.
5 times 5. And 12 is 2 times 2 times 3. And then I multiply across, and I get 15 over 7. Feel okay? All right, let's think here real quick. God bless you.
Thank you.
God bless you.
Thank you.
All right, first step is to,
Factor.
no,
You changed what?
yeah, rewrite it as a multiplication problem. When I was in elementary school, they said, dividing fractions is easy as pi, flip the right and multiply. Yeah, rhyming. Yeah, that's how I remember it still.
Wait, is Pi Day this Friday?
Might be. Yeah, the pie eating contest, I think,
Yeah.
is Friday, isn't it? You signing up, Gabby?
No.
No. Are you gonna watch it?
I'll let Caden handle that.
Okay.
He's good at it.
It's also kind of gross,
It's
isn't it?
so nasty. Last year he like shoved it all together.
Yeah, you ever watch the hot dog eating contest on
I
TV?
won't watch that.
My
I
God.
know.
Why would anyone?
Like the dunking everything, they dunk everything in water so that it goes, they can just swallow it and it can chew.
Okay, alright.
Like they eat the hot dog separately and then they dunk the buns and just kind of drink them. It's very gross.
I wanna go back to much rather hear about that than that.
Yes, I don't blame
I
ya.
agree.
All right, let's factor x squared minus 3x
Now it's
minus
factor
4.
time.
It's factor time. You're just one step too early.
2, no. 2 and 1, no.
Nope.
X plus 1, X minus 3. 4. Sorry.
That's correct.
I'm so bad at it.
How about the denominator, x squared minus 2x?
x plus 1, wait, no.
Only so
You take out an x.
There you go, Nick's got it. Just factor out an x.
Let's go, Nick.
Plus 1
And then can I factor x?
No,
Can I factor x plus 1?
no.
All right, let's reduce.
You guys look like you're studying. I'm scared.
You can't do anything
Nothing.
about that because it's like
Something
after
to-
minus negative.
No, I just find what you guys are doing too worse.
Thank you.
What do you guys think? It's okay?
I think they're doing something totally opposite of that.
I do too.
I think that makes a lot of sense though.
Yeah, those are really.
I'm gonna expect you to be able to do this like tomorrow then, Mary.
Do we have a homework
Whoa.
quiz?
I don't know, that might be coming up really soon.
It's probably gonna be on Wednesday.
Do you hate us or something?
Well, would you rather do it this week or next week during Irish Week?
Oh, this,
Yeah, exactly.
Oh.
Yes, this
Sorry.
week. You're right.
I didn't mean to
Just
say
You're,
that.
no, it's the right answer. I am not hating you, or I would save it to next week.
What if
You
we
wouldn't
don't
give
do
us
it?
a test on Irish Week,
Scroll so I
right?
can see the end of it.
The end of what?
Okay, wait, never mind.
Dang it, I got the Rangers.
Is it on Friday?
Mr. Kulik, you wouldn't give us a test right before Irish Week, right?
I might give you a test during Irish Week.
Are you, wait, what?
So what's the? I think I'd rather have a quiz rather than a test on
Wait,
Irish Week.
what?
I don't know, I just have to look at the, I haven't looked at the days real hard.
Do you think maybe we should do it like after?
I'd take the quiz
We're
during Irish
seniors, it's
Week.
not that deep.
All right. Next up is adding.
Oh, wait, that's it? Okay.
Yeah, we finished it.
Oh, I'm sorry.
Yeah, it was like x minus 2 over x, or x minus 4 over x, x plus, x minus 4 over x minus 2.
X minus 4 over X minus 2, got it.
Yeah, that was the end.
I like this side of calculus.
Thanks for sharing, Nick.
Yeah.
So we start by doing a prime factorization. Then we need to multiply the top and bottom of each fraction to make the least common multiple in each denominator. That means that what I multiply the top and bottom of fraction 1 could be different than what I multiply the top and bottom of fraction 2 in almost every case they do. Once we do that, we multiply the numerators out and add them up, and that'll give us our final answer over the, over the least common multiple. So let's do this. Again, I only care about the denominators. What's the prime factorization of 12?
2 times 2 is 3.
God help me, you know it by now, because we did it 3 times now.
Oh.
And then 20.
5 times 2 times 2.
Okay, I'm gonna write it as 2 times 2 times 5, but you had the right numbers, and that's all that matters. Order isn't important. Okay. So what's the least common multiple of 12 and 20 going to be then?
2 or
Oof. 4 is the greatest common factor.
oh 2. Oh wait. 1.
Okay, so it's gonna have each distinct prime factor needs to appear in the least common multiple. I see 3 distinct prime factors, 2, 3, and 5. Then I need the biggest power of each of those prime factors. So I have a 2 squared, so the power on 2 has to be 2. I have a 3 to the first, so the power on 3 has to be 1. I have a 5 to the first, so the power on 5 has to be 1.
Wouldn't it be 2 to the 4?
That would not be the least common multiple. So I can find a number that is divisible by both 12 and 20.
60.
That is 60.
Okay.
So again, 60 divided by 12 is 5. 60 divided by 20 is 3. 60 is the least common multiple. It's each of those two numbers divides it. There's nothing smaller that both those numbers will divide. Everybody okay? Again, the way you find it, you have each distinct prime factor needs to be in the least common multiple. And then the power on each of those distinct prime factors is the biggest power of that factor in any of the numbers present.
So only in the numbers, like you wouldn't do like 2 to the 4.
Correct. Because I have, 2 squared times 3, 2 squared times 5. The biggest power on a 2 is 2. It's not to take all the powers of 2. Oh, no. I want the biggest power of 2 in either number. The biggest power of 2 in either number is to the second.
So like, I think one you have like 2 to the first, and the other you have 2 to the second.
It's still 2 squared, at least common multiple. You're right.
That makes sense.
Yes.
I've never done least common multiple like this before.
Yeah, this is we have to do it this way because when we start getting polynomial factors, it's confusing to not do it this way. So I want to go back to numbers first and show it to you because it's fairly easy. Addie, are you okay?
I'm fine.
Okay,
It's just a lot.
that's okay. So if we go back up here, I have 7 over 2 squared times 3. And I'm going to have 11 over 2 squared times 5. Now, I'm going to look at what do I need to multiply this fraction by to get 2 squared times 3 times 5 in the denominator. So I need to make this denominator into this value. What is this denominator missing?
5.
5. So that's what I'll multiply the top and bottom of this fraction by. Now I'll look at my second fraction. I have 2 squared times 5. I need that to turn into 2 squared times 3 times 5. What is this denominator missing? 3. Is everybody okay? And how I figured out what I need to multiply each one by? And let's check if we can reduce. I should probably add that to the list. I'll put a little question mark after it because it's not always possible. Prime factorization of 68 is 2 times 2 times 17. Whoa, Mr. Kulik. That was fast. You know it, guys. Notice at no point did I bother multiplying out the denominator until the very, very last step, right? Doesn't help me. If I need to reduce, it's better to have that denominator in factored form. I'm never going to write that denominator as 60 until maybe the very last step if there's no reducing to do. Guys ready to try this with the polynomials?
Yeah.
Yeah, let's do it. Okay.
So is the homework quiz gonna be Wednesday or Friday?
Oh, one of those days.
What are you leaning more towards?
Well, let's think about it. If I want both A period class and B period class to do it this week,
Oh,
you do the math on that one.
right.
So on Friday, right?
No.
No. Next class.
What are we both doing next week?
Because it's Irish week, and you guys will bellyache even harder about
You're
it.
literally gonna give us a test.
Yeah, details. You want to do both next week?
No.
No, see? It's better. You're not going to fail this class. Get the heck out of
I
here.
should be. I'm not even joking.
Only if you just keep staying behind, you're not getting caught
I'm
up.
so like behind everything.
All right, let's see here. I want to do. No. Everybody's okay? I'm gonna start by factoring. Only the denominators though, I don't care about the numerators. Only the possibly check if there's any reducing to do. But like, fat on me if there's reducing that you could do before you have to add or subtract. That's a pretty poorly designed problem. How do I factor x squared plus 4x plus 4? Everybody other than Gabby get the same thing? Come on, guys.
Can you just write it?
And I'm gonna write that as that way.
Okay. I was just gonna ask.
Probably the better way to do it.
Is it easier that way?
I like to do it that way
Okay.
because when I'm adding and subtracting, I really care about the powers of the prime factors,
No.
not so much listing them out. So I tend to do that. All right. And then my next one is, how does that one factor?
X.
Okay. But the denominator is what I care about.
I'm so bad at this.
Is it x minus
5 and 2.
2x?
Yes, there you go. I heard multiple people firing that one out. Good job, multiple people.
That's me. No problem.
Okay.
Anytime.
What's my least common multiple gonna be? How many distinct prime factors do you guys see?
X plus 2 squared.
Okay. Just,
Darn.
how many distinct prime factors do we see?
I don't know.
I see x plus 2 and x plus 5.
2.
2 distinct prime factors. The biggest power on my x plus 2's is
3, right?
2.
to the second.
But you don't include the one on the right?
Well, I see a power of 2 and I see a power of 1. What's bigger between 2 and 1?
Oh, you don't have one. Okay.
2, right? Okay. What's my biggest power on x plus 5?
1.
1. That's my least common multiple. Am I ever going to FOIL that out? God, no. right? Like what a useless waste of time, and it's gonna be like a long time, because that's a lot of foiling to do, right? Nobody wants to do that. You do not do that. Never ever.
Let me see this.
Okay. All right. So I need to make this fraction have this as the denominator. What's missing from the denominator to turn it into the least common multiple?
X plus 5.
X plus 5.
X plus 5. That's what I'll multiply to the top and bottom. What do I gotta do to this one?
X plus 2.
Good. Is everybody happy with what I've done so far? You guys can all handle this?
Yes.
Okay, you like doing it as the least common multiple, like writing that out and like how to do that? All right. I'm gonna multiply the numerators out now. How do I have to multiply x minus 3 times x plus 5? I have to FOIL that. I'm gonna do that quickly in my head. Does anybody object? And then I'll multiply x times x plus 2. Again, distributing there, I don't actually have to FOIL. Everybody okay? I'll combine some like terms. Notice at no point have I multiplied out the denominators, right? Everybody still doing good? My last step now is going to be checking to see if I can factor the numerator, because there could be some reducing hiding here. What stinks about this though? Now the leading coefficient isn't 1, right? So I need like the two numbers that multiply to give us negative 30, and then add to give us 4. Are there two numbers that do that? Do 1 and negative 30? Does negative 1 and positive 30? 2 and negative 15? Negative 2 and positive 15? 3 and negative 10? Negative 3 and positive 10? 5 and negative 6? Negative 5 and positive 6? Those are all our factors of negative 30. So what's that tell you?
It's done.
It's done. There's no reducing to do. I'm going to leave my answer in the factored form. Notice that the top is prime. There's no factoring we could do on that. That is done. It is factored. What do you guys think?
This.
It's all right. Adding and subtracting harder, right?
Yeah.
Okay. Let's do a subtraction problem. Is anything going to happen meaningfully if I change this to subtraction?
Not much.
Not much, right? We just have to be a little bit careful. First step should be, oh my gosh, I'm going to do this. I'm going to make this one little change here. Just do that. Sorry. Otherwise, it would just reduce it.
Oh my gosh.
It'd be stupid, Mr. Delay. Okay. Yeah, let's factor them denominators. How do I factor 2x cubed minus 4x squared?
Take out 2x squared.
Take out a 2x squared. How do I factor x to the fourth minus 2x squared?
Take out negative.
Oh!
Oh, wait, no.
Let's do this. Sorry. Let me just do that. Make it x to the fourth minus 2x cubed. I do that. Don't be too mad at me.
Figure out x to the x.
Yeah, that makes the problem easier, Mr. Kulik. Sometimes when you're making these up on the fly, you're like, I got it. And you look at it and you're like, I don't got it. Sorry for the changes.
Do you just make these up in your head?
Yeah.
As we go? Oh, that's a smell. Yeah.
Yeah, when you've done this for 20 years, you could do it too.
I don't think I could.
Yeah, you undersell yourself. Imagine doing the same class over and over and over for 20 years. But not just you're taking the class for 20 years, you have to like talk to people through it for 20 years. How good at this would you be?
What did you do
Pretty good.
before this?
I was a production chemist, was my previous job before I was a math teacher.
So what would you like do?
What's that?
Synthesized chemicals.
Oh,
Whoa.
So like orders would come in for novel chemicals that my company produced, and I would be in charge of, like synthesizing that, and we send it out for the analytical team would analyze and make sure that like it is what it is and the purity level is above a certain level, and then they send it off to shipping and they ship them out.
So you could be like a chemistry teacher?
Yeah. All right. Least common multiple. How many distinct prime factors do you guys see?
2. No, 1. No, 3. It's okay.
There are 3. Here's the $100,000 question. What are the 3 distinct factors?
Oh, 2x squared, x minus 2, x to the third?
No.
What? I'm just like, I was something.
The 3 distinct prime factors are 2, x, and x minus 2.
Oh, okay. I see. Wait.
What is the biggest power of 2 in any denominator?
1.
To the first. What is the biggest power of x?
3.
3. What is the biggest power of x minus 2? 1. This is why I did this problem where it's a very common mistake for students to think x cubed and x squared are distinct prime factors. They are. The prime factor there is x. They're just different powers. Does everybody feel okay? Okay. All right. What do I need to multiply the first fraction by to get that?
2.
X. Because I have the 2, I have the x minus 2, but I have an x squared instead of an x to the third. I'm missing one factor of x.
Wait, so does that, oh wait, no.
Let's look at the second second fraction. I have the x cubed, I have the x minus 2, don't have the 2.
So 2.
So 2. Everybody's okay? Now what do? I multiply out the numerators. This is 100%. If you're going to make a mistake on doing this, this is where you're going to make the mistake. Super common mistake. I'm going to say it like 5 times here, and still over half of you are going to make this mistake on a test. Because it's a subtraction problem. When I multiply through, I need to multiply through by -2. when I do this, when I grade this problem on the test, over half of you are gonna write a +2 there because you're not gonna distribute the negative. I'm gonna say it one more time to make sure on these subtraction problems that you're distributing through the negative, because I know it takes at least 3 times of saying something before everybody in the class will hear it. And even then, I have my doubts about, Grace who's got her head down, or Charlie and Isaac that are having their own private conversations about whether they're hearing it or not. So I'll say it one more time, just to try to reiterate, even though I don't think it's gonna make any difference, that on these subtraction problems, I need to make sure I'm distributing through the negative.
Okay,
We got it.
distribute through the negative.
Yeah,
Oh, good one, Daddy.
and it's great. You remember today, the big test is, are you gonna remember tomorrow, and the day after?
And the quiz day, and then the test that we have on every sign on the board.
Yeah.
Guys, are we ready for the quiz next hour? Next hour.
Okay,
What were you doing?
so now what do we do? Combine my like terms.
Wait. Did we just say 6-7? And then this even, it wouldn't have been that.
And I reduce, and what's my final
Isn't
answer?
that funny if it wasn't because it was
2x,
Wait,
one
oh.
over, 1 over
It
2.
would have been that funny if she had the confidence to say it was less funny because she stopped it and then just said well, I wasn't gonna say it. Okay, why did you say that? That's my first thing.
Are we done for the day?
Okay, wait.
Yes,
Okay, wait.
yes.
Oh.
Wait.
What is this?
Wait.
No, what is that?
Mr. Fowler, can I go to the bathroom? Are you? Wait.
Yes.
Thank you.
Small numbers.
What is that? What is that? What is that?
It's a worksheet.
Oh,
What do you think it was a test or something?
2. Yeah.
Have you ever been at something before?
I haven't.
Oh, it's so much fun.
My 6-year-old daughter will begin the asking. We're still on for a couple of years away from that though.
Yeah. I'm still probably in the house, but not the
Wait,
greatest.
what was the asynchronous stuff? Because I was thinking, but I was working on my sister's.
Chapter 14 Delta Math was this.
That's it.
So this guy, worksheet 2. This is your homework for today. This will be part of Sunday's problem set. So whether you do this on this sheet or on a separate sheet of paper, gets loaded into the OneNote either way. I do not want it back from you guys. I just gave you the printout because I feel like you like this better if it's a handout assignment rather than like doing it on the OneNote.
Wait, when was the chapter 14?
Yep, that would be good. And then same with the
Yes.
So I can do a delta math like this.
Yes.
No.
As long as it's in by Sunday, and you can email it about.
actual Saturday was doing, or Sunday was doing.